Hello everyone, welcome to today's class. We're going to continue with our topic of integration and we'll look to the method that's substitution, one of the most relevant method in integration. Okay, this right now it's a topic for us. When we'll progress through the integration, it will be some intermediate step. Okay, so a question can have multiple formats, and in those formats you can have substitution as one part, then standard results, or setting the questions as per the integration. So far what have we done? We have done only basic part. Okay, so basics were like slight adjustment and we got to the standard part of it. Now same thing pretty much we'll do with the substitution. Okay, so some adjustment and substitution will work. There's no such formula for substitution, although you have to identify what you have to substitute. So I'll teach you that with the illustrations that will be upcoming. Okay, remember this idea. Whatever is asked for integration, the weirdest expression that looks in it, okay, the weirdest one, okay, that will be your thing to be substituted. Like if I ask in this question, suppose this is a question and you have to integrate, okay, like this, 2x sine bracket x square plus 1. Now what is the weirdest looking thing? This sine. Why this is weird? Because x square plus 1 is present in it. So this is what is making this sine looking weird, because otherwise if it was sine x, it would look simple, but this is sine, inside it x square plus 1 is there. So this is the weird part. So I'll let x square plus 1 as some t. This is the first step of substitution. So we assume it some simple thing t. Now see, the integration is right now with respect to dx. We'll generate dx. We'll differentiate both sides. So differentiation of this is 2x. Okay. As such, we are differentiating with respect to x. Okay. For now. Okay. Differentiation of this 2x. Differentiation of t will be dt by dx. Okay, if we take dx here, we get 2x dx is equal to dt, and this is, we are going to do this for only one time. Okay, from now onwards what we'll do is we differentiate x square plus 1, we put 2 dx with it. We differentiate t. What is the differentiation of t? 1. We put dt with it. Okay, but background process is this, so no more doing of this step. Directly come to that, x square differentiation dx, t differentiation dt. Okay, all right. So if you look at this part now, 2x dx, this is all set to become dt. Okay, so what this question will look like now? This question will look like this: integration, this 2x dx becomes dt, and this sine x square plus 1 is t, sine t dt. I think after that is very simple. What is the integration of sine? Minus cos t plus c. But see, the question started with x, so our answer should also be in x. Okay, so that will be minus cos x square plus 1 plus c, and that's your answer for this. Okay, simple idea. Whichever is the weirdest looking part, that will be your t. Look at this question. All right, so we have to integrate this again with respect to dx. Look at this expression, which is the most weirdest one. Tan power 4 sec square. Fine, inside them both is the root x is present. Okay, so the weirdest thing is right now is that inside tan there is root x. So what I'll do is, first of all, I can take root x as some t. Let's take root x is equal to some t. Okay, we'll do this in 2 steps, and then I'll teach you how to do this in 1 step. So root x is t. Okay, so precisely what is the differentiation of it now? So root x differentiation, directly I told you, 1 by 2 root x, put dx with it. Dt differentiation will be 1, put dt with it. Okay, and if you look at this, see, dx and root x are already present. What is the thing that is required here? We required 2 here. So we put 2 in multiplication with this, and in order to do the adjustment, I have to put another 2 in the numerator also. So the question will look like this now: integration tan raised to power 4t sec square t dt. Okay, because this dx to root x becomes dt now. Okay, still not too much simplified, but again, if I ask you which one is the weirdest one still out of this, you'll say that because of this power 4, this tan is weird. Okay, I can take tan raised to power 4t as some new variable, let's say z, but I'll not take that. Why? You'll see in the next step. If I take tan t as z, okay, so we can do multiple substitution also. Again, I'm doing the substitution. I'm letting the tan t as some z. So what is the differentiation of tan t? Sec square t. Differentiation of t will become dt. Z differentiation is 1 dx. Okay, like this. Whichever variable you are differentiating, put dt, dx, dz with it. You see this again. Sec square dt. This is already becoming dz. Okay, and tan t is your z. So what is this integration looking like? Z raised to power 4 dz, and now it becomes simple. What is the integration of z raised to power 4? Increase the power, z raised to power 5 by 5 plus c, but the question started with x. So first of all, put z as tan t. So tan raised to power 5 t upon 5 plus c, and your t was actually root x. So tan raised to power 5 root x upon 5 plus c. Okay, I've done it with lengthy approach. We can do this in one step also. I'll take the same question and show you how this could have been done in one step. Okay, so remember, it's not always that you have to look so much into the question that it has to be done in one substitution. There is no certain rule that a question will be done in one substitution. You can do multiple substitution. Whatever you want to do, you can do accordingly. Of course, if we do it in one substitution, you have to look really forward at what is going to happen and what is going to be utilized. But this is the idea. You can do multiple substitutions also. Okay, so I've shown you this. We did 2 substitutions here. First x root x as t, and then tan x with z. All right, let's look at this now. If I really want to do this in one step, what is the weirdest looking thing? I'll say the weirdest one is, because of this power 4, tan root x is the weirdest one. So let tan root x as t. Okay, what is the differentiation of that? The reason I'm taking tan only, not power 4, because I want to generate sec square. Okay, that's the reason. So you have to look forward that what is going to be generated when I differentiate something. Okay, sec square needs to be generated, so that's why I'm taking tan only. So tan differentiation is sec square root x, then chain rule. Root x differentiation is 1 by 2 root x. Okay, I think there was one 2 also ongoing. No? Yeah, this 2 was still in the multiplication, 2 was in multiplication. So the whole answer is being actually multiplied by 2. So this, and you put dx with it. Differentiation of t will be 1 dt. Okay. Look at this. Sec square is there, sec square is there. Dx is in the numerator, dx is in the numerator. Root x in the denominator, root x. We need 2. Again, do the same adjustment. Multiply 2 here also. Numerator and denominator. The question will look like integration. Tan root x is t na. So this is t raised to power 4. Rest everything is becoming dt, including this 2. Okay, this was required. Na? So what is the integration of t raised to power 4? So you will say t raised to power 5 on 5 plus c. 2 was outside. So 2, what is t as such? T is tan raised to power 5 root x upon 5 plus c. Okay. So of course you will like this approach, but see, you have to, get the correct idea what needs to be substituted. Okay, both the approaches are fine, both are giving the correct answer. It's just that one approach is showing you 2 substitution, one approach 1 single substitution. Okay. and typical questions will have multiple substitutions. You might not be able to see that in one substitution it can be done or not. All right, next question. This one is simple. If I ask you which is the weirdest looking thing, dx, you'll say because of this tan inverse inside sign, this is making even sign weirder. So I'll take tan inverse x as t, let. Then differentiation of this 1 upon 1 plus x square dx is dt. That's already there. Okay, dx is there, 1 upon 1 plus x square is there. That is effectively going to become dt. So the question will look like this only: integration sine t dt. And again, it's very simple: minus cos t plus c, or minus cos t is tan inverse x plus c. Okay. All right. See, the question will never tell you that it is of substitution. While doing indefinite integral, there are multiple ideas possible. That's why if you have to choose between indefinite and definite, indefinite is slightly typical. Okay. Now, using this same substitution, I'll give you one idea. We have the property. One second. I think it's time now. This one. The 4 results now. It's time to discuss this. Ax plus b we have already discussed. Okay. Now standard results. Integration of tan is minus log cos x plus c. Okay. And sometimes it is also written as, if you take negative in the power of cos, that will become log mod sec x plus c also. Point is how this is coming. I'll show you. Okay. So these are the standard results upcoming. These all results are being derived from substitution. Integration of tan x, you have to learn that. Minus log cos x, integration of cot, log sin x, integration of sec, log sec x plus tan x, integration of cosec is minus log cosec plus cot. Okay, these 4 results are based on substitution. I'll give you one idea to how to get these results. Okay, and show you the application of substitution. So the question, this is not a question as such, and this is a property, that integration tan x. Okay, we have to do this. Okay, so far we didn't have the integration of tan. We had the integration of sec square, that was tan, but not directly tan. Okay, tan square we did integrate using the property sec square minus 1. Okay, so first of all, let's write down this as sin x dx upon cos x. And what you do is use the substitution. If I ask which one is the weirder, sine and cos both are weird, but if you really have to choose the denominator. Let cos x is equal to t. Then differentiation minus sine x, put dx with it. Differentiation of t1 into dt. There is no negative sign with sin x dx. If you look at this, sin x dx, sin x dx, this is here, but there is no negative sign. So let's adjust. Put a negative here, put a negative here for the adjustment. So negative of integration, the numerator becomes dt, denominator becomes t. What is the integration of 1 by t? That's log mod t plus c. And what was our t? Minus log mod cos x plus c. Okay. So using this result, you can derive sine, cos. Same way, slightly you will be able to do sec. Sec is not direct. I'll show you how sec gets derived. Integration of sec x dx. Okay. So we need to do the adjustment. The adjustment goes like this. What do? We multiply this with sec x plus tan x. Okay, with numerator and denominator. I know it's a weird step, but yeah, we do it. And now that we have multiplied both numerator and denominator by this, let's literally multiply the numerator. That becomes sec square x plus sec x tan x, and the denominator is sec x. Means this time we are forcing the question to become weird. Okay. if you look at which is the weird expression, you might say numerator, but let's take denominator as t in this. Let sec x plus tan x as t. You'll see the differentiation of this becomes sec x differentiation is sec x tan x plus tan x differentiation is sec square x dx is dt. Okay. You see this whole thing is present here. So that makes it integration, numerator becomes dt and denominator becomes t. Again same idea, log mod t. What is our t? Sec x plus tan x plus c. So I have derived two formulas just for you to understand that all of these formulas are being derived using substitution. Even the formulas below is also derived using substitution, but right now I'm not discussing those. Those are again a special subtopic, that is standard results. Okay, but right now these four formulas will use. So tan x integration minus log cos x, cot x integration log sin x, sec x integration log sec x plus tan x, cosec is minus log cos x plus cot. Okay, all right, we're done with this. Now let's proceed. Four formulas done. Let's integrate few questions. So this time you have sine cube x, cos square x. Okay. Although this will be separately discussed in trigonometry, but still the idea is regarding substitution, so I'm discussing here also. We'll discuss this under a special subcategory also. So the interesting part, if I write this as sine square x cos square x into sin x dx. Why I'm writing this? Because this power was odd, no? That's why. Now for the time being, if cos x was t, see, I'm just guessing the idea that let cos x is t, so minus sin x dx is dt. Okay, that is present here, minus sin x cos dx. Okay, sin x is there, at least negative we can always adjust. How can we adjust? Put a negative here, put a negative here. Okay, all right. If we do this, our integration becomes, this becomes dt. Cos square means t square. What about the sine square? Sine square can be written as, sine square x is 1 minus cos square x. That means 1 minus t square. So this becomes 1 minus t square. And now we can integrate. Just multiply with this, t square minus t raised to power 4 dt. And now this becomes a standard question. Just increase the power. T cube by 3 minus t raised to power 5 by 5 plus c. T is cos x, cos cube x by 3 minus cos raised to power 5 x by 5 plus c. So the hint for this question is t is equal to even power trigono expression. You have to take t out. See, usually the confusion begins that whether I should take sin x as t or cos x as t. So idea is that even power expression of trigo will be your t. Okay. All right. Next question. Look at this. A good question as such, but not so much typical, but still a good question. Again, how is this related with substitution? You see your numerator and denominator both as sine. Okay, which one is weird, x or x plus a? So I'll say slightly x plus a is weird, so let that be t. Let x plus a is t. Okay, so what is that? Dx is equal to differentiation of x is 1, so dx, differentiation of t is 1, also dt. Okay, so you'll say that nothing is going to happen. then denominator becomes sine t, but numerator is sine x. If x plus a is t, that means x is t minus a. So this becomes t minus a. You'll say it's not, nothing really happened here. What happened is a weird expression was in denominator, now it's in the numerator. So what is the overall benefit? See, the benefit is now that it is a minus b. You can use the property and expand, and you have a single denominator which is easier to split. So this becomes integration of let's use the property. Sine a minus b is sine a cos b minus cos a sine b. Oh, sorry, b, I'm writing sine plus b. Okay, you need the property of sine a plus b, sine a minus b. Trigo will never leave you in integration. Trigo will be a key part. Differentiation, integration, trigo will always be there. So learn those properties upon sine t. So I'll split it in this. Sine t here also, sine t here also, sine t here cancels. So good thing here, cos by sine is cot. So this becomes integration of cos a minus sine a cot t dt. Okay. Now before solving this, you have to understand that what was the variable and what is the constant. A is a constant. Okay. So this whole thing is a constant. What is the integration of a constant? Just put x with it. So x cos a minus, what is the integration of sine a cos t? So right now again this is constant. So leave that, because it's in multiplication. We'll integrate only cot t. What is the integration of cot t? Okay, tan was log minus log cos x. This is log mod sine t. Okay, plus c. And now oh, this was in t, sorry, my bad. Yeah, so one important thing, we are integrating with respect to t. So integration of constant will be not x, it will be t. Okay, remember that, casual mistake. And now put the value of t. T was actually x plus a. So x plus a cos a minus sine a log mod sine bracket x plus a plus c. Yes, a very weird answer, but that's it. Okay. At least we got to the formatted form, no? Okay. All right, this is done. Let's look at the next question. Next one is even extreme. Next one is even weirder at a whole another level. The kind of setting this uses is like looking into the future as such, that something is going to happen. Whenever you are doing maths, you always get some particular kind of questions which have a very unique approach. If you have not done that kind of question, definitely you will not be able to attempt that in the exam. This is that kind of question. Okay, this is not going to be done in first time. You learn this in first time, and next time you see this kind of question, you will be able to do. Okay, so for this, seeing the things, it's slightly typical. Just look at the steps, how the substitution is going to happen. Let's convert first of all this in sine and cos. So this becomes dx upon this becomes 1 plus sine x by cos x. I'll write here. Yeah, this is a lengthy question, so it's going to take the whole page as such. So integration 1 upon 1 plus sine x by cos x dx. Let's take the LCM. So integration 1 upon, this becomes cos x plus sine x, and this cos x in the denominator will go in the numerator. Okay, cos x dx. Now what I'm going to do is I'll multiply this by 2 and then divide by 2. Okay, look at the setting. Then I'm writing this 2 cos x as cos x plus cos x. We'll see why. I'm going to introduce additional plus sine x because I want my numerator and denominator to match, so I can cancel them. But if I'm adding something, I have to subtract something. Okay, so this is the second adjustment. I have added sin x, I have subtracted also sin x. Okay, and now you split the denominator in two parts. Okay. So this becomes cos x plus sin x. This also becomes cos x plus sin x. Okay, this cancels effectively 1 by 2 is with the whole integration. 1 plus cos x minus sin x upon cos x plus sin x dx. You'll think what is the overall purpose? Still we managed from a simple question to a weirder looking expression even, but weirder is better, na? Why? Because substitution works on those. If I ask you to choose the weird expression out of these, numerator and denominator both have sine and cos, plus and minus, of course you'll say denominator is weird because it makes the integration tough. So let cos x plus sin x as t. Differentiate this. So minus sin x plus cos x dx is equal to dt. Isn't this the same expression? This color is not okay. Let me get a light color. This is okay. So this in expression is already present here. It's just that order is written differently. That's everything is same. So good thing now. I told you for substitution, weird is better. Okay. The simple the question, it's tough. You see, the question starts with a simple idea, 1 plus tan x, and we had to do so much adjustment in it. Okay. All right. 1 plus numerator becomes dt, denominator is t. I think after that it's very simple. Okay. One problem. I think it's better if we split the integration in two parts. Okay. Integration of this and integration, because this was already 1, because otherwise it will confuse you. 1 dx and this. Okay, so because you might think the integration here was t. Okay. Earlier also was this or not? No, earlier was this. Okay. Okay. So 1 dx plus this is integration dt by t. Now it's okay, because one integration you will not write t, this time it's with respect to x. But with respect to x, so this is x plus 1 by t is log mod t plus c. So the whole answer is 1 by 2 x plus log mod cos x plus sin x plus c. That's your answer for this question. Substitution was the easy part at the end. It's the adjustment of the question that takes time. That what's make integration tough. Okay, you'll never have the problem with applying the results. It's the part till you get to the appropriate step where you can actually apply that integration rule. Okay. All right. Now that we have done this, based on this question, I'll give you one question to practice. You can practice this. Not one, I have two questions as such. You can practice this on your own. Same idea, same thing. Whatever you get in the numerator, multiply by 2, then do this kind of adjustment. So 2 questions for your practice, same idea. Okay. Integration 1 upon 1 minus tan x you can do dx. This will be based on the same idea, and integration 1 upon 1 plus cot x. Okay, the simpler they are, the typical the substitution will become. Okay, let's do same as above for practice. Okay. All right, we knew some questions now. Let's do some easy questions now. Very easy looking question, but it will get you comfortable with the substitution. Okay. I'll get the whole question set. All right. Let's do the first one. Integration 2x dx. Yes. Numerator and denominator, which is weird. By default, denominator it has 1 plus x square. So let 1 plus x square as t. So 2x dx is dt. That is present here. 2x dx. So this integration becomes, numerator becomes dt, denominator becomes t. Log mod t plus c log mod 1 plus x square plus c. Okay. Next one, we'll do this quickly. Dx log x square, sorry, log x whole square and x. Fine, denominator is weird, but log is even weirder. So I'll take log x as t. Let log x as t. Okay, suppose you take log x whole square as t. Your substitution is wrong. How will you know? You try to attempt that. You'll see you will not be able to do the adjustment that is going to happen in the next step. Okay. If that's not happening, that means whatever you have let the t as, that is slightly wrong. So I have to adjust that accordingly. So not taking log x whole square as t, log x only as t. So differentiation of log x is 1 by x dx as dt. Okay. You'll have to develop some knack about it. Okay. So integration. So this is present here, na? 1 by x dx, that's your dt. So this log x is t, so t square dt. Integration of t square, t cube by 3 plus c. That is log x whole cube by 3 plus c. Next, 1 by x plus log x log x. Before even solving the question, what I can see is both the expression x and x log x have x in it. So I can take it common. So 1 by x, 1 plus log x. And now that you know that whenever x is present in the denominator and you have log also present, you can take log x as t. Rather taking log x, take this whole expression 1 plus log x as t. So that makes let 1 plus log x as t. So log x differentiation 1 by x dx is dt. Here it is. This is making it dt. Integration dt. Denominator is only 1 plus log x, that's t. So 1 again log mod t plus c. So what's our t? So log inside 1 plus t is 1 plus log x, so 1 plus log x inside a log, and there is mod also present, so mod plus c. That's the answer. Okay. Simple straightforward questions. Let's look at this question. All right. Next question. Sine x, and then you have sine bracket cos x. I don't have to tell you, which is weird. This cos x is weird inside it. So let cos x as t. Then minus sine x dx is dt. That's present here. But minus is not there. So what we'll do? We'll put a negative here, but put a negative outside also, and we'll take this sine x dx negative as dt. So integration negative sine and cos x is t. So sine t dt. What is the integration of sine t? Minus cos t. So negative of negative, it becomes positive, plus c. So cos bracket cos x plus c. That's your answer. And this question. 1 second. dt. This is a question that we've already done one time using a property of 2 sin a cos b. But I am going to do this with substitution now. Sine and cos both are looking slightly weird. So what we'll do is, We'll take cos ax plus b as t. Okay, or if you want you can take sine also, both is same. So let's take sine, because you have a habit of going for sine first rather than cos. You are taught also like this, you taught sine first and then cos. So let sine ax plus b as t. What is the differentiation of sine ax plus b? Cos ax plus b, and then differentiation of ax plus b also, that is a. Dx, okay, is equal to differentiation of t is dt. A is not present, so what we'll do? We'll put another a here, and since we have multiplied this by a, we have to divide by a also. Now this a cos ax plus b dx is becoming dt. So your integration will look like 1 by a. Okay. I'm going to erase this because it's going to, I'll highlight this, sorry, this and this. Okay. So 1 by a, and sine ax plus b was t, na? So the whole expression is t. 1 by a t dt. What is the integration of t? 1 by a t square by 2 plus c. Okay. So 1 by a t is sine square ax plus b by 2 2a like this plus c. That's your answer. Okay. And if you go through the answer of this question while doing we did this in the basic, you'll see that the answer is not going to match. The problem is that our integration answers are not unique. Means you may be able to integrate a question, but the answer may not be unique as such. You can have different answers. You and your friend suppose did the same question, but your approaches to do the integration is different. Your answer will be different. Both can be correct, but still they can be looking different. Okay. So remember that differentiation is unique, integration is not unique. Then let's do this. Very simple question. Integration of x square root of x plus 2. X plus 2 inside is the square root, so this is making it weird. Okay, because of the square root. So let it be t. So let x plus 2 is equal to t. So this is integration dx. Okay. So integration of dx, sorry, differentiation of x plus 2 is 1. So 1 dx. Differentiation of t is also 1 dt. So let's put the value. Integration dx will be replaced directly by dt. Root x plus 2 becomes root t. What about this x? So let's generate x. X is t minus 2. And you might think this has not made the question so much different than the previous question one. Okay. Look at this. Integration, it is t minus 2 root t dt. Okay. We can multiply this root inside this t minus 2. So it becomes 2 root t is t raised to power 1 by 2. So this is t raised to power 3 by 2 when you multiply by t minus 2 root t dt. What is going to happen? Integration of this directly you can do. This becomes t raised to power 3 by 2 plus 1, 5 by 2, then 2 by 5 minus this is actually t raised to power 1 by 2. So 1 by 2 will become 1 by 2 plus 1, 3 by 2 into 2 by 3. Okay. Plus c of course. Now put the value of t. 2t was square root, sorry, x plus 2. So x plus 2 raised to power 5 by 2, 2 by 5 minus 2 to the 4 by 3 x plus 2 raised to power 3 by 2 plus c. Okay. Replace your t with x plus 2 now. Next question, again very simple. All right. again integration dx, which is weird, of course, the thing which is inside the square root. So 1 plus 2x square is t. What is the differentiation? Do it the differentiation. 1 differentiation is 0. 2x square differentiation is 4x. Put dx with it. Differentiation of t is 1 dt. 4x is not present. X is present. So what will you do? You will multiply by 4. You will divide by 4. And now you take 4x dx as your dt. So this becomes integration 1 by 4 dt. And square root, what is inside the square root? T only. And now we can integrate easily. 1 by 4, this becomes t raised to power 1 by 2 plus 1, 3 by 2 into 2 by 3 plus c. So 2 and 4 can cancel. This becomes 1 by 6. T is 1 plus 2x square complete raised to power 3 by 2 plus c. After substitution, replacing the value of x is not a problem, but it's just that to get the correct substitution, that's the key part. That's why I'm discussing so many questions, so you get a feel of it. Okay, getting the feel of integration is very important. Okay, and the more questions you do, you get the question and you'll see. It's like it's a practice and learn process. For other chapters, you learn the formulas, learn the formats, and you can do the question. Okay, for integration, formats only will not be able to help you. The formula sheet that I've given is not sufficient to do any question. You can see how much settings are going on, how much variations are there in Trigo. Every single question can be slightly different. Okay, one slight variation, one new idea. Okay, let's look at this one. Again, same thing. Which is the weird one inside the square root? Okay, so let x square plus x plus 1 is t. So differentiation of this is 2x plus 1 dx dt, but we don't have 2x plus 1. But if you look very carefully, if you take 2 common out of it, what is this? 2x plus 1 square root of x square plus x plus 1 dx. And now you have your dt. 2x dx is 2x plus 1 dx is dt. So the question will look like this. Integration, this whole thing becomes dt, and square root of this means square root of t. Same idea again. 2 t raised to power 3 by 2 into 2 by 3 plus c. So 4 by 3. T is x square plus x plus 1 complete raised to power 3 by 2 plus c. Okay. All right. The questions are never, I mean, I'm not saying the questions cannot be lengthy. It's just that few questions are very simple to do. It's just that you have to see through really the question. Okay, you have to really see through the question, whether substitution will work or what should I do in the question. That's the always the problems the student face. Even I was facing the same problem when I was learning integration, that how do we really know what kind of integration to use. Okay, the key is only practicing the formats. Now look at this very weird expression. Point is, you don't even have something to substitute. Okay, this is x, this is root x, and they are in subtraction. But what is x actually? X is root x whole square. That means I can write this as root x whole square, and now I can take root x common. Okay, so one step, root x whole square minus root x dx, and you'll see now you have something to substitute. 1 upon root x minus 1 dx. Now out of these, both expression are in the denominator. If I ask you which is the weird one, this is the weird one. So let that be t. So let root x minus 1 is equal to t. What is the differentiation of root x? I told you to learn that. 1 upon 2 root x dx. Okay, one differentiation is 0. T differentiation is dt. So interestingly, you see you have root x in denominator. You have dx also. All you need is 2. You know how you have to do? Multiply 2, do the adjustment, this question becomes 2 integration of dt upon root x minus 1 is t. So what is that? 2 log mod t plus c. So 2 log mod t is root x minus 1 plus c. That's your answer. Okay. All right. That one you will be able to do now. Look at this. This is okay. All right. X cube minus 1 complete raised to power 1 by 3 x raised to power 5. You have to integrate this with dx. Kind of weird looking expression, but which one is more weirder? This one, because the power of 1 by 3. So let x cube minus 1 into, is dx. X cube minus 1 is t. So differentiation of that is 3x square dx. That's your dt. Now we don't have 3, we don't have x square also, but if you again readjust your question, this is x cube minus 1 power 1 by 3. X raised to power 5 can be written as x square, x cube into x square. Okay, so we have generated x square dx. All we need is 3. We know how to adjust that, or we can put it outside the integration also. It's a constant now, so let it be. Now we have generated 3x square dx. I don't like this color. Let's change it. Yellow. Yellow is better. Fine. Okay, so 1 by 3 integration. This x cube minus 1 is t. This is dt. What about this x cube? So let's get the value of x cube. X cube is t plus 1. So use that. So into t plus 1, and this power is 1 by 3. Okay. Now what you can do? You can multiply this. 1 by 3 integration t raised to power 4 by 3. 1 by 3 plus 1, 4 by 3. Plus t raised to power 1 by 3 dt. And now you can integrate. So 1 by 3 integration of this will be plus 1. No. So 1 by 4 by 3 plus 1 is 7 by 3. So this will be 3 by 7 plus 1 by 3 plus 1 is 4 by 3 plus 3 by 4 plus c. Okay. So you can replace the value 1 by 3, 3 by 7, t is x cube minus 1. No? So x cube minus 1 raised to power 7 by 3, 3 by 4, x cube minus 1 raised to power 4 by 3 plus c. That's your answer. All right, done with this. Let's look at another question. You get the idea now, at least. Let's look at this. Let's do all the questions. Integration dx. Numerator and denominator. You have to select which is. This one is weird. So 2 plus 3x cube is t. Differentiation of this 3 power 3 will come down, 9x square dx dt. All we really need is 9. So multiply 9, divide by 9, and that's it. This is integration. Numerator becomes dt, denominator becomes t cube. 1 by 9 is also there, so 1 by 9 into minus 3 plus 1 minus 2, so 1 by t square, and minus 2 also in here. Okay, plus c, so that is minus 1 by 18, t is 2 plus 3x cube plus c. Okay, done. Next question. I hope you are getting the whole idea regarding the substitution now. That's why I'm discussing so many questions. Again, 1 by x, log x. The moment you see 1 by x and logs, you know what you are going to do. Okay. Why is this written? This is written to make this valid, because I told you that inside log, the quantity has to be greater than 0. So, okay. So that has nothing to do with the question as such. It's only making the function defined. So same thing, which is weird. Log x is t. 1 by x dx is dt. Okay, I'll erase dx from here and write it here. So 1 by x dx. Okay, so that's your dt. So integration dt upon log x is t, so t raised to power m. What is integration of 1 by t raised to power m? So you get this in the numerator, that will become integration t raised to power minus m dt, and now you integrate. So t raised to power minus m plus 1 upon minus m plus 1 plus c. So that makes it t was log x. So log x raised to power, I can rewrite this as 1 minus m upon 1 minus m plus c, and I think adjustment was all okay. Yeah, done. Right. Next, let's do it here. This one is also very simple. Try to guess the substitution, what you are going to substitute. I think you have the correct idea here. What is that? The denominator. The whole denominator is weird as compared to numerator. What is 9 minus 4x square left? That is t. What is the differentiation? Minus 8x dx dt. Minus 8 is not here. Fine, we'll provide it. We'll multiply by minus 8. We'll also put minus 8 here. So the integration will look like minus 1 by 8. Numerator becomes dt, denominator becomes t. I think rest is simple. Minus 1 by log mod t plus c. Put the value of t. Now I'm not putting. We have done plentiful question. You know you have to leave the answer in t. Okay. I've done the integration part now. You can do the rest. Okay, next, very simple question. Okay, dx e raised to power x square. Now what is weird? Of course, it's expression of e, but let me show you what happens if you try to take e raised to power x whole square as t. What is the differentiation of e raised to power x square? So you let this function as z. What is the differentiation of e raised to power z? E raised to power z into z dash means differentiation of x square, that is 2x. Okay, dx is equal to dt. Can you see something like this here in the numerator? X is there, but e raised to power x square is not there. So this was the thing I was talking about. So even if you take something which was not supposed to be your t, it's okay. Leave it. This is not working. Try something else. Let x square as t, because e is okay. Is the power that is creating the problem. Now let x square as your t. If x square is t, 2x dx is dt. X dx is there. All we have to do is adjust 2. So that makes it right. So you'll have to work it out on your own. Okay, it's not that you'll always get the substitution correct in first step. Okay. So the question will look like 1 by 2, 2x dx becomes dt. Okay. This whole thing becomes dt, and denominator is only e raised to power t. Okay, because x square was t, na? All right. So it actually is 1 by 2 integration of e raised to power minus t dt. Now, what is the integration of e raised to power minus t? E raised to power x, you know. What about e raised to power minus x? Na? That's the whole point. So the whole question is how to integrate e raised to power minus x. It's not tough. It's just that you have to relate it. That what is the idea? This is nothing but ax plus b format. A raised to power minus x integration is e raised to power minus x only. It's just that coefficient of x. What is the coefficient of x? Minus 1 will come in the denominator, or as such it is minus 1, so it doesn't matter, will come in the numerator also. 1 upon minus 1. Whatever is the coefficient of x, you get that in the denominator. That's the only thing you have to understand. This is not a formula. I'm just relating it with ax plus b format that we have studied. So 1 by 2. Usually if it was e raised to power 2x plus 3, you will be able to identify, yes, it is ax plus b format. It's just that whenever it is only e raised to power minus x, student get confused that now what we have to do. Either it's only e raised to power minus x. So the integration is minus e raised to power minus t plus c. So minus 1 by 2 e raised to power minus t. What's minus t? E raised to power minus x square plus c. So if you want, you can do the reciprocal, rest everything is okay. All right, let's slightly increase the level, slightly, very slightly, but it's not tough. Let's do a few questions regarding e. Okay, e raised to power integration dx, e raised to power tan inverse. See, e is okay, but the power of tan inverse makes it weird. So let tan inverse be your t. Let tan inverse x is t. What is the differentiation of tan inverse x? 1 upon 1 plus x square dx is equal to dt. That's already present here. That's dt. So the question is now integration e raised to power t dt, and rest is simple. What is the integration of e raised to power t? E raised to power t plus c. E raised to power tan inverse x plus c. Okay. All right. Not a toughie. Simple question. Let's look at this now. Again, same thing. We are going to do some questions on based on e. E makes it, I don't know why, but examiner have the tendency to give a question regarding e. I don't know why, but the moment you see e raised to power, something happens to the student and they feel very weird about this. Same thing with this question. You see very weird kind of expression, both numerator and denominator, e raised to power 2x minus e raised to power minus x 2x, e raised to power 2x plus e raised to power minus 2x. Now, which is the most weird? Both are equivalent, but we prefer denominator to be t. Let's try. Let's see if the substitution will work or not. Okay. If this is t, then let's differentiate this. E raised to power 2x differentiation is e raised to power 2x into 2. E raised to power this minus 2x differentiation is e raised to power minus 2x into minus 2. Dx is equal to dt. But 2 is not present here. Same expression. You see, the same expression is present. I'll erase this. The same expression is present here. E raised to power 2x, e raised to power 2x minus e raised to power minus 2x. Only 2 is not present. So what can we do? we'll multiply each term by 2. Okay, basically we are multiplying the whole numerator by 2, so we have to divide the with 2 also. Okay, so I've multiplied 2 and then distributed along this, so the whole expression becomes your dt now. I think after that this becomes very simple question. Numerator is dt, denominator is t, log mod t plus c log mod e raised to power 2x plus e raised to power minus 2x plus c. Simple enough, easy enough. But there is always a but in the mathematics. What if this happens? Okay, another good question. Let's see. You'll say this was working here, so why not here? Let's do the same thing. Let's take the denominator as t. Fine, let's try it. Let's see what's going to happen. Okay, if we take e raised to power 2x plus 1 as t, differentiation of this is e raised to power 2x into 2, 1 differentiation is 0, so this is dt. So this part is present, but minus 1 is not present here, so you cannot take the whole numerator as dt. So this substitution is not working. What then? I told you this is a good question, so let's see. What I'm going to do, the first step, you might find it weird, but after doing the first step, you'll be able to see what is going to happen. I'm dividing numerator and denominator both by e raised to power x. Okay, you'll see in a minute why. So if we divide this, so e raised to power 2x by e raised to power x minus 1 upon e raised to power x, that's numerator division, denominator also 2x by x minus 1 by e raised to power x dx. I'm showing the proper steps, you can do directly also. If we divide this, same base, power gets subtracted, so e raised to power x, if I take this in the numerator, e raised to power minus x, denominator e raised to power x, e raised to power minus x. Look at this question and look at this question that we have discussed, question number 20. You'll see the resemblance in this. When both the terms have e raised to power, the substitution was working. That was the reason I divided both numerator and denominator by x, e raised to power x. Now you'll ask, how will we know whether we have to divide by e raised to power x, e raised to power 2x or something else? So the idea is, whatever is the power here for this format only, okay, whatever is the power head, that divided by 2, you have to divide by that power. Means 2x divided by 2 is x, so you have to divide by e raised to power x. Okay, that's how we know. So this question can be modified, although I have never seen this kind of question, but e raised to power, let's say 4x minus 1 upon e raised to power 4x plus 1. So in that scenario, you have to do the same step. It's just that you have to divide numerator and denominator with a half of this e raised to power x. That's the key idea. Rest everything is simple now. I think I copied the question wrong. Denominator was plus, denominator was plus. Yeah, now it's okay. Now you take your denominator as t and your numerator will become dt. Okay, let e raised to power x plus e raised to power minus x as t. Differentiation is e raised to power x minus e raised to power minus x dx as dt. That is present here as dt, so it becomes integration dt by t, which is log mod t plus c log mod e raised to power x, e raised to power minus x plus c. That's the answer. Okay, all right. Okay. Next question. I'll put all the questions which we are going to do after this. You can keep trying. Okay. This one also. All questions have pretty much the same idea. Substitution, substitution, substitution. Okay. Let's look at these three questions. Sine inverse square root of 1 minus x squared dx. This we have to integrate. Most weird, both numerator and denominator slightly, but I'll have the preference to sine inverse. Inverse functions are very, very weird. So let sine inverse x as t, and you'll see that the differentiation of sine inverse is the denominator itself, dt. Okay, so this expression becomes dt. So this is integration of t dt, that's t square by 2 plus c sine inverse x whole square plus by 2 plus c. Okay. All right, this question, 6 cos x plus 4 sin x. Okay. 2 cos x minus 3 sin x. First of all, you can see the factor of 2 common here. So let's take it out. Integration 1 by 2, 2 cos x minus 3 sin x. Denominator becomes 3 cos x plus 2 sin x dx. Okay. Numerator, denominator pretty much looking like same. If I have to guess something as t, I'll take this. Okay. Denominator as t. If I take this as t, what is the differentiation of this? Time I'm not trying to write it. Let's see directly. This is t. So 3 cos x differentiation is minus 3 sin x. 2 sin x differentiation is 2 cos x. The whole numerator is going to be your dt. So again 1 by 2 dt by t integration, that's 1 by 2 log mod t. Okay. 1 by 2 log mod 3 cos x 2 sin x plus c. This one lastly, integration dx. Cos is okay, but root x inside it, no, let it be x. Let root x is equal to t. 1 by 2 root x, sorry, denominator, no? 1 by 2 root x dx is dt. There is no 2 with root x in the denominator. You multiply it by 2 and 2 here. Do the adjustment. So now you have the question 2 cos t, and this whole thing becomes dt. Cos t dt. What is the integration of cos? That's sine t. So 2 sine t plus c, 2 sine root x plus a c. Okay. All right. Next one. Let's take this one first. integration cot x log sin x dx. Okay, so cot x log sin x, no? So what you can do is, which is weird, cot is okay, but log has a sign present inside it. So if you, even if you take cos sin x as t, still the question, I'm not sure it will modify too much, because sin x differentiation is cos x. Right now we cannot see cos present here. So let the whole log sin x be t. Okay. So let log sin x as t. What is the differentiation of log sin x? So log differentiation is 1 by sin x, and then sin x differentiation is cos x dx. Isn't this the cot? This is cot x dx. So the substitution is working. So integration log sin x was t, cot x dx is dt. I think after that it's done. T square by 2 plus c. Okay. So t is log sin x, and don't write square sin square, log sin x whole square by 2 plus c. That's your answer. Okay. Now I'll show you 3 questions, all based on same idea. I'll solve one of them, remaining 2 are for your practice. Okay. We'll do the first one, remaining 2 will be homework for your practice. Okay, look at the 3 questions. All have a single trigonometric expression in the numerator, and denominator they have 1 plus 1 plus something. Okay, 1 plus cos x. What is the differentiation of cos x? Sin x. That's why it's here. What is the differentiation of sin x? Cos x. That's why it's here. What is the differentiation of cos? Again, sin x. Okay. So the whole idea is to take the denominator as t. As simple as that. So, okay. So dx, dx, dx. I'm going to solve only one. This one. Now I'm not going to take whole square, because we want to generate sine na, for substitution. So let only 1 plus cos x as t. So differentiation of this, minus sine x dx is equal to dt. Negative we can adjust, put a negative here, then put a negative outside also. So the question is now negative integration of minus sine x dx is dt. Denominator is only t square. What is the integration of minus what is the integration of 1 by t square? So it will be t raised to power minus 2 plus 1. So negative effectively, na? So my t raised to power minus 1 upon minus 1 plus c. So it becomes negative, negative cancels. So it becomes 1 by t plus c. So 1 by 1 plus cos x plus c. Okay. These 2 are for your same practice. Take this as t, take this as t. You can solve this. All right. Only a few questions left. Let's finish them. You see root sine 2x and then cos 2x. You have to integrate, which is weird. The thing present inside square root because of the square root. So let sine x be Sine 2x is t. Why? Because differentiation of that will generate cos. So cos 2x dx, and then another differentiation of 2x is 2 is dt. 2 is not here, so fine, we'll give it 2. Put another 2 in multiplication, then put 2 in division also. This whole thing, 2 cos 2x dx basically becomes dt. So integration root t dt, and 1 by 2 also. What is integration of root t? T raised to power 1 by 2 integration is t raised to power 3 by 2 into 2 by 3. 2 cancels, so 1 by 3 t raised to power 3 by 2 plus c. So 1 by 3 t was sine 2x raised to power 3 by 2 plus c. That's the answer. This is done. Few questions are going to practice. Let's do this. Next question. This is interesting. All right. The setting in this question will, it's not very difficult. It's only very slight adjustment, but it is there. It's not going to happen automatically like for most of the question. Of course, which is weird. Denominator can be, but square root is there. So select that. So what is present inside that square root? Tan x. Okay, so tan x as t. The problem is sec square x dx is dt, which is not here. Okay. Now either you adjust it or you force your substitution on it. There are two ways to do this. Let's force it, or adjust also we can do. Let's adjust it. Okay. But if we force it, then you won't have to do anything. The question will automatically happen. So fine. We can do this by force, or we can do this by adjustment. So let's force it. You like that approach also. Adjustment you have seen a lot. So root tan x, we are doing the substitution. So root tan x is t. The problem is there is no sec square here. So what do? We'll literally multiply forcibly by sec square and then divided by sec square. So far the adjustment that I've done was based on the idea that we were forcing a constant, but this time I'm forcing a variable. Let's see if it works or not. So this thing sec square and this becomes dt. Okay. But still you have terms sine x, cos x and sec square x. Okay, so we have to get that also in terms of t. So what is sec square? Basically 1 by cos. Okay. So integration root t dt. This is sine x, cos x, 1 by cos square x. Okay. We can cancel this cos with 1 cos. And what is sine by cos effectively? Sine by cos is tan x. And what was actually tan x? T. So root t by t dt. Okay. So this is also one way to force the substitution. So this is 1 by root t dt. What is the integration of 1 by root t? That's 2 root t plus c. So 2 root t was tan x plus c. Okay. So we force the substitution. Usually the adjustment that we do is regarding the constants, never with the variable. But we can do about that also if you are finding it difficult sometimes. Okay. All right. This kind of question is also done now. All right. 2 more questions and we are done. Look at these 2 questions. First one, let's do. you have to integrate this dx. It's a very weird looking expression, so I'm happy about this. Why? Because the more weirder the expression looks, the more easier the substitution is. Okay, x plus 1, okay, x plus log x whole square. First of all, x and log x are being added and there is a whole square of it, so why not take this as t? Okay, denominator is simple, clearly we can see. So x plus log x is t, so differentiation of x is 1 plus 1 by x is dt. Let's simplify this. So basically x plus 1 upon x dx was there, no? Is dt. Dx. You can see this is already present, x plus 1 x dx. That will make your dt. So the whole question is actually nothing but integration x plus log x was t square dt. Just one substitution, it makes the question like a piece of cake. T cubed by 3 plus c, t is x plus log x whole cube by 3 plus c. Same thing about the last of this question. Which is the most weird looking expression? X raised to power 3, fine. Sine, there is a tan inverse x raised to power 4 inside it. Okay, so let that be your t. Tan inverse x raised to power 4 is t. What is the differentiation of tan inverse? But the problem is that inside tan, x raised to power 4 is there, so use chain rule. So first tan inverse differentiation, 1 upon 1 plus x raised to power 4 square. Then differentiation of x raised to power 4 is 4x cube. Okay, and then dx is equal to differentiation of t is dt. Okay, 4 is not here, so fine, we'll provide 4. And the integration is like this, dx now. So see this adjustment, 4x cube, 1 upon 1 plus, what is x raised to power 4 raised to power 2? X raised to power 8 na? So same thing. So this whole thing is dt. So what's the question actually? Integration sine and the thing present is t, rest is dt. What is integration of sine t? Minus cos t plus c, so minus cos tan inverse x raised to power 4 plus c. That's your answer. Okay. That ends your substitution. It's not the completion as such, but from my end, that's pretty much it about substitution. That should be more than enough help to go through the whole concept, how this substitution works. Okay, we'll see the substitution in the upcoming lectures also, but that will be an intermediate step. These particular questions that we have already done, these were direct questions on substitution. Okay. So we'll see this substitution in the upcoming lectures also, but not as a key part. Okay, and it's actually very simple, and I gave you the idea. The more weirder the question looks, the simpler it is actually, and the idea is mostly about your substitution. All right, that's it for this lecture. See you in the next class. Good day everyone. Bye.